There is no article in the 2005 National Electrical Code, or NEC, that explicitly states a ground fault circuit interrupter, commonly referred to as GFCI, receptacle can be installed where no grounding wire is present. The NEC, a widely adopted standard for safe electrical installation, sets specific requirements for GFCI protection and grounding. To understand this better, let's delve into the functions of a GFCI and the role of grounding. A GFCI is a safety device designed to protect individuals from electrical shock. It works by monitoring the current flowing into and out of a circuit. If there is an imbalance, even a small one, indicating that current is leaking to ground, the GFCI will quickly trip, cutting off the power. This rapid response minimizes the risk of severe electrical shock. Grounding, on the other hand, provides a low impedance path for fault current to return to the source. This path helps to trip the circuit breaker or fuse, disconnecting the power and preventing a sustained fault. A properly grounded system ensures that metal enclosures and conductive parts of electrical equipment are at or near ground potential, reducing the risk of shock. While a GFCI can provide a degree of protection against electrical shock in the absence of a grounding conductor, it does not replace the function of grounding. Grounding is still essential for safely clearing faults and preventing voltage buildup on conductive surfaces. The NEC addresses the use of GFCI protection in various sections. Section 210.8 covers GFCI protection for personnel in dwelling units and other locations. This section outlines specific areas where GFCI protection is required, such as bathrooms, kitchens, and outdoor locations. However, it does not explicitly permit the installation of GFCI receptacles without grounding in new installations. The NEC does provide some allowances for replacing existing receptacles in older homes that do not have grounding. Section 250.130c describes the replacement of non-grounding receptacles with grounding receptacles and GFCI protection devices. This section outlines that where an existing receptacle is non-grounding type, it shall be permitted to be replaced with a grounding type receptacle where supplied through a GFCI protection device. Also, a non-grounding type receptacle shall be permitted to be replaced with a GFCI protected receptacle. These allowances recognize that retrofitting grounding conductors in existing buildings can be challenging and costly. In such cases, GFCI protection can provide an enhanced level of safety. However, it is essential to understand that these are exceptions, not the rule. In new construction or when extending circuits, grounding is typically required. When replacing a non-grounding receptacle with a GFCI protected receptacle, it is required to mark the receptacle with the words GFCI protected and no equipment ground. This marking informs users that the receptacle is protected by a GFCI but does not have a grounding connection. Several factors are contributing to the NEC stance on grounding and GFCI protection. Firstly, grounding provides a reliable path for fault current, ensuring that circuit breakers or fuses trip quickly. Secondly, grounding helps to minimize voltage buildup on conductive surfaces, reducing the risk of shock. Thirdly, grounding provides a stable reference point for electrical equipment, which is important for proper operation. In conclusion, while GFCI protection can enhance safety in older homes without grounding, it is not a substitute for grounding in new installations or when extending circuits. Always consult the latest edition of the NEC and local electrical codes for specific requirements in your area. Remember, electrical work can be dangerous. If you are not comfortable working with electricity, always hire a qualified electrician. Understanding the code requirements for GFCI receptacles and grounding is crucial for ensuring electrical safety. While GFCIs provide valuable protection against electrical shock, they are not a replacement for proper grounding. It is essential to follow the NEC and local codes to ensure that electrical systems are installed safely and correctly. Let's further elaborate on the specific sections of the NEC that address GFCI protection and grounding. Understanding these sections will provide a clearer picture of the code requirements and the reasoning behind them. Section 210.8, as previously mentioned, covers GFCI protection for personnel. This section outlines the specific locations where GFCI protection is required in dwelling units and other occupancies. The list includes bathrooms, kitchens, garages, outdoor locations, crawl spaces, unfinished basements, and boathouses. The requirements are based on the increased risk of electrical shock in these areas due to the presence of water or conductive surfaces. For example, bathrooms are particularly hazardous due to the presence of water and grounded plumbing fixtures. GFCI protection is required for all receptacles serving bathroom countertops. Similarly, kitchens are also considered high-risk areas due to the presence of water, conductive surfaces, and grounded appliances. GFCI protection is required for all receptacles serving kitchen countertops. Outdoor locations also pose a higher risk of electrical shock due to the presence of moisture and contact with the ground. GFCI protection is required for all 125 volts, 15 amps and 20 amps receptacles installed outdoors. Section 250 covers grounding and bonding. This article provides comprehensive requirements for grounding electrical systems and equipment. It covers topics such as grounding electrode systems, equipment grounding conductors, and bonding of metal parts. Grounding electrode systems are designed to provide a connection to the earth, providing a stable reference point for the electrical system. Equipment grounding conductors are used to connect metal enclosures and conductive parts of electrical equipment to the grounding system, providing a low impedance path for fault current. Bonding is the process of connecting metal parts together to ensure that they are at the same electrical potential, reducing the risk of shock. Section 406.4d addresses the replacement of receptacles. This section provides specific requirements for replacing existing receptacles, including the use of GFCI protection in certain situations. As mentioned earlier, this section allows for the replacement of non-grounding receptacles with grounding-type receptacles where supplied through a GFCI protection device, and for the replacement of non-grounding receptacles with GFCI-protected receptacles. These allowances recognize that retrofitting grounding conductors in existing buildings can be challenging and costly. However, it is important to note that these are exceptions, not the rule. In new construction or when extending circuits, grounding is typically required. When replacing a non-grounding receptacle with a GFCI-protected receptacle, it is required to mark the receptacle with the words GFCI protected and no equipment ground. The reason for these requirements is to ensure electrical safety. Grounding provides a reliable path for fault current, minimizing the risk of shock. GFCI protection provides an additional layer of safety by detecting and interrupting ground faults. By following the NEC requirements, electricians can ensure that electrical systems are installed safely and correctly. It is also important to note that local electrical codes may have additional requirements. Always consult the local electrical inspector for specific requirements in your area. In addition to the NEC sections mentioned above, there are other sections that address GFCI protection and grounding in specific applications. For example, Section 680 covers swimming pools, fountains, and similar installations. This section has stringent requirements for GFCI protection and bonding due to the increased risk of electrical shock in these environments. Section 547 covers agricultural buildings. This section also has specific requirements for GFCI protection and grounding due to the presence of livestock and conductive surfaces. Section 550 covers mobile homes and recreational vehicles. This section has requirements for GFCI protection and grounding to ensure the safety of occupants. By understanding these various sections of the NEC, electricians can ensure that electrical systems are installed safely and correctly in a variety of applications. It is important to stay up to date with the latest edition of the NEC and any local electrical codes. Electrical codes are constantly evolving to reflect new technologies and address emerging safety concerns. Regular training and continuing education are essential for electricians to stay informed and competent. In addition to following the NEC and local codes, it is also important to use good workmanship practices. This includes using proper wiring techniques, making secure connections, and protecting conductors from damage. Poor workmanship can compromise the safety of an electrical system, even if it is installed according to code. For example, loose connections can cause overheating and arcing, which can lead to fires. Damaged conductors can create short circuits or ground faults. It is also important to use the correct materials for the job. Using undersized conductors can cause overheating and voltage drop. Using improper fittings can create loose connections or expose conductors to damage. By following good workmanship practices, electricians can ensure that electrical systems are installed safely and reliably. It is also important to inspect electrical systems regularly for signs of wear and tear. This includes checking for loose connections, damaged conductors, and malfunctioning devices. Regular inspections can help to identify potential problems before they become serious hazards. For example, a loose connection can be tightened before it causes overheating and a fire. A damaged conductor can be replaced before it creates a short circuit or ground fault. By inspecting electrical systems regularly, homeowners and business owners can help to ensure the safety of their property and occupants. If you are not comfortable working with electricity, always hire a qualified electrician. Electrical work can be dangerous. A qualified electrician has the training and experience to perform electrical work safely and correctly. They also have the tools and equipment needed to do the job right. Hiring a qualified electrician can give you peace of mind knowing that your electrical system is in good hands. In summary, understanding the requirements for GFCI receptacles and grounding is essential for ensuring electrical safety. While GFCI protection can enhance safety in older homes without grounding, it is not a substitute for grounding in new installations or when extending circuits. Always consult the latest edition of the NEC and local electrical codes for specific requirements in your area. Remember, electrical work can be dangerous. If you are not comfortable working with electricity, always hire a qualified electrician. Electrical safety is everyone's responsibility. By following the NEC local codes and good workmanship practices, we can help to prevent electrical accidents and injuries.